All right, so let's go ahead and go over the warm-up. We're going to first check, make sure you know the parent function format and that kind of things for the exponential and power. So on numbers 1 and 2, we're on page 13 in your packet. On problems 1 and 2, how do you know if it's exponential versus power? What indicates that? Okay, good. So if we have plain x and logged y, then it's an exponential equation, and the x is the exponent in the exponential transformation. The x is the exponent in the exponential transformation. And then we unlogged the a and the b. Now when you unlogged this b, make sure that you are unlogging negative 0.256. So don't forget to notice those negatives. And that gives you this predicted y. Don't forget your prediction hat, and if there is context, write it in context. 19.95 times 0.56 to the x, if you were going to 2 decimals. All right, the second one, we knew it was power because logged x and logged y. And so then the x is the base and the slope itself is the power, and it's unchanged. So this is the 2.5. Just like over there in the problem, slope was 2.5. All right, so let's go through the rest of these quickly. Number 3 was an exponential. Predicted y is 7.75 times 0.27 to the x. And the next one was power. Predicted y was 14.69 times x to the 1.85. I'm getting questions. How does it matter how I write that parentheses and such? And the answer is no. I wrote it in both ways, the exponent in the parentheses or the exponent out, and the bottom line is that if you do order of operations correctly, it is the same either way, so it technically doesn't matter. I don't know why I wrote it different ways. Have no idea. Okay, moving on. Number 5 was exponential, 22.39 times 6.24 to the x. 6 is power. Predicted y is 37.15 times x to the negative 0.985. Okay, so making sure that you are noticing the negatives. Don't forget that. And then number 7 and 8. 7 is predicted y is 5.82, x to the 3.25, and predicted y is 35.48, x to the negative 2.5, because that was a negative slope. All right, questions there? Yes, ma'am. Just do 2 decimals is fine. Oh, wait, sorry. 2 significant digits. Two significant digits. Do you know what that is? Like, yeah, 0.25, or you could go 0.056. 2 significant, it could also be 0.05, and if this was a 0, you may or may not write it, but that's significant, considered significant.
In the decimals or just the whole number?
It's in the decimals. The significant digits are in the decimals. All right, now the next part is we got to go over these multiple choices because I need to make sure, I'm going to go over conceptual understanding things here, not just, okay, real quickly, here's the answer. So there's going to be kind of some review things going on here in my explanation as well. So for this first one, they did a linear transformation, or they didn't do a transformation. They just graphed linear, and there's the prediction line, and then there's the data in the residual plot. So we see a pattern in the residual plot. Answer choices A, B, and C all reference the original data. So they are saying exponential, parabolic, or cubic problems should be predict the x and the y. X and y. So they're trying to claim what the original looked like and say that the original looked like exponential, a parabola, or a cubic. And that is, you can't really do that. You cannot, from the residual plot alone, Go backwards and tell definitively what the original graph looked like. For example, it could look like this. You could have that line in there, and then you got the points around it like that. But you could also have x and y, and then you could have your slope as a negative. You don't know that, and then you know you've got your data around it. Okay? These are just in simplistic form. You cannot definitively say what the original looks like just from the residual plot. All right, so A, B, and C are out. D says there is greater variation for low midterm scores, and you see all of these being far apart, okay, than for midterm scores that are high. These have less variation. So that is true. D is true. But let me talk to you why E is not. Students did better on the final exam than they did on the midterm. Well, you don't know that because this residual plot just tells you how they did compared to what? How they were predicted to do. So you don't know where this prediction line is. I mean, this prediction line, like this could be 100. If they got 100 on the midterm, then, you know, this right here could be a 50. You don't know if their actual prediction line is a low final exam score or not. All you know is how these guys did compared to predicted. You don't know how that was necessarily what that final score is. Okay. All right. There's that. Next. Okay, so what this problem is saying is that this is the original data. This is your x and your y. So it's critical that you're paying attention to is it the original data? Is it the transformed data? What is it? So as you can see, and as they tell you up here in the problem, they say that the original data will be fit best by an exponential model. So the original data will be fit best by an exponential model. Well, if it's fit best by an exponential model, how do I transform it? X and log y. So the transformation x log y compresses that data, and it makes it linear. And that's what you wanted to happen. So it takes that original data and it compresses it to make it linear so that you can get a linear equation for log y equals mx plus b. And then once you have this, you can unlog it to compute that. Okay, so let me say that again because that's essentially the whole rigmarole of what's happening. You recognize your original data isn't linear and needs to be transformed. You transform it, and that transforming smushed it so that it made it linear. So you get the equation, the linear equation to fit the transformed data. Log y equals mx plus b. Then unlog it so that it will give you this curve value right here that fits the original data. Okay, so that's what's happening. Let's then go back over here and answer these questions. So once you have that going on, the A and B say, an attempt is made to fit a straight line to the data shown. And then it references the residual plot. So let's make a sketch of the residual plot. If this is this prediction line, what will the residual plot look like? The dots will first be what? Above it. Looks like we got dots above it over here. And then they're going to curve below it. And then they're going to be above it. So, in that residual plot, is there roughly a straight line pattern? Is there a straight line pattern in this? No. Is there a random pattern in this? No. there is a curved pattern in that, so there definitely is a pattern in that residual plot. So a linear model wasn't appropriate. Now, I want to go over question C, even though it's old-time review stuff. Let's talk about it. It says an attempt is made to fit the straight line, and so they sum the squares of the residuals. Okay, so do you remember that game when we did Boys Against Girls? When somebody came up here, they did the residual, made a square out of it, then the other residual, you make a square out of it, another residual, you're making all these squares from the residuals, and those areas were added up. What was the goal? How did you know it fit the best? It was the smallest. We knew that it fit the best if we had the smallest sum of squared residuals. Okay, the residuals squared. All right, but based on the fact that these are areas and they are squared numbers, when I sum these up, can they ever equal 0? No, they are always equaling a positive number, and our goal is just to find the smallest sum. So what's happening then in that answer choices there, the answer choice is saying that they should equal 0, and so that's a no-go. But let's talk about this. If this is your line and I just straight up ask you for plain residuals, you will have positive residuals, and then you will have these positive residuals, okay, if your points were above this. And then you have negative residuals. We're not talking about squared ones, we're just talking about their actual values. What can you say about the positive residuals plus the negative residuals? Those do sum together. So the positive and the negative residuals do sum to 0, but not if they're squared, such as referenced here. Okay, so that was kind of a review thing way back to October, but I wanted to remind you of that since we're getting here to the end of the learning. All right, D says, plot log y and x will provide a approximately linear pattern. And what was the very first thing I showed up here? If we did x log y, they told me since that fits, then that's going to make ourselves a linear pattern, which will get log y equals mx plus b for. That is why D is the answer. Now, look at E. E says if you logged the y and you logged the x's, that would make a linear pattern. We know that's not the case because this was told to us to be exponential. Had they told us the fit is accommodated by predicted y equals ax to the b, which I know is a power model, if they had told us that function fit it best, then I would have the answer choice E, because then I would be saying the log x and the log y fit it the best. All right, questions there. Moving on to the last one. Okay, so this last one says, hey, here is the linear transformation of just plain old yx equals mx plus b. And what do you see about this? There's a pattern in the residual plot. So your conclusion is what? Linear model is not good. Linear is a no-go. All right, so if linear model is a no-go, then we're going to transform it. And according to this information, with log x and log y, what kind of transformation did they do? Power. And then we look at the residual plot of that. Here's our residual plot. We could be a little concerned. Anybody think, well, it still looks a little bit more varied out there. Okay, I hear you. But of the two options, residual plot 1 and residual plot 2, which one yields a better residual plot, showing that it's a better fit? Residual plot 2 shows that that model is definitely a better fit than linear, so I know power is a better fit. So down here, we are told the linear of x and y is a no-go, so A and B are out. It is nonlinear because it is power, so those options are good. Regression 1 is not the better one. You guys told me regression 2 yields the better. That's why it is E. But let's discuss C, because we want to remind ourselves of this. Remember that correlation has the same sign as slope. So, what kind of correlation would we have? In both cases, you know, they leave no doubt that we have positive correlation. So answer choice C, saying there's a negative correlation, is a no-go because we've got positive slopes in both of our functions that we fit. Okay, questions there. All right, then we're going to quiz that, and I am also going